Hey guys, welcome to lesson 6.2, where we begin discussing the binomial distribution. So a typical, uh, a binomial distribution is one where you have a fixed number of trials, two outcomes per trial, hence the bi and binomial. So for example, if I flip a coin, it's either going to be heads or tails. There's only two possible outcomes. It's not like you're pulling a marble out of a bag of marbles and there's three different colors, right? That would be three different outcomes. Independent trials, so that means the outcome of one trial doesn't change the probability after that, and the probability stays the same. So one kind of classic example is free throws. So a player makes 75% of her free throws. So long term, she's a 75% free throw shooter. And she shoots 5 attempts. So here we talked about fixed number of trials. So the trials are set in advance. So it's not a situation where she shoots until she makes 5 free throws. She shoots 5 and then counts how many of the 5 she made. So n is equal to 5 fixed before she starts. Each attempt is either made or missed, so hit or miss. Attempts are independent. So one shot doesn't change the next. And her probability of hitting a free throw is always 75%. So we would say this is a binomial distribution with n is equal to 5. N is the number of attempts, and the probability of success is 75%. Now, we're not going to go into the mathematics of how to calculate all these different probabilities, but we will use a Staplet app that will let you navigate this. All right, so if she shoots 5 free throws, there's 5 possible outcomes. She can make 0 out of 5, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, and 5 out of 5. And for each of those outcomes, there is a associated probability. So her probability of hitting 0 out of 5 free throws, if she's a 75% free throw shooter, is 0.001. Her most likely outcome is hitting 4 out of 5 free throws. She roughly has a roughly 40% chance of hitting 4 out of 5 free throws. Then the next most likely outcome is she hits 3 out of 5. And the next most likely outcome is she hits all 5 out of 5 free throws. And that happens 23.73% of the time. Then 2, then 1. The most unlikely outcome as a 75% free throw shooter is she misses all of them. She goes 0 for 5. Now, on Staplet, if we go to binomial distributions, we can plot this scenario. So she is shooting 5 free throws and is a 75% free throw shooter. So there's the distribution and there's the different outcomes. If I wanted to know the probability that she hits exactly 4 out of 5, this would be 0.3955. All right. So the probability of hitting exactly 3 out of 5 would be, we said, let me see, exactly 3 out of 5. I did 4. All right, so I want exactly 3 out of 5 would be 0.2637. Now, if the question was, what's the probability that she hits exactly, or that she hits at least 3 out of 5? At least 3 out of 5 would be 3 or 4 or 5, right? All of those would count. So the nice thing is this app can do that for you. So at least 3 out of 5 would be 89.65% or 0.8965. All right, so at least 3 out of 5 would mean she hits 3 or 4 or 5. 1 second. There we go. And you can explore the different options on this app. You can do less than, at most, at least, more than, right? So more than 2 doesn't include 2. More than 2 means 3 or 4 or 5. At least 2 would include 2. So be kind of sensitive to what it's asking when you fill in the answers. Blood donors. So here in this situation, 7% of people have a zero-negative blood type. So is it binomial? Yes, you either have a zero-negative or you do not. It's a universal donor type. A blood drive registers 200 donors, none related to one another. That makes a difference. If you have 15 people come and they are from a from a close family, then there's likely to be some correlation between their blood types, some sort of relationship. All right, so you've got 200 donors, and I want to know how many of those 200 will have a zero-negative blood type. So 200 donors, that's fixed. Each donor either has a zero-negative blood type or not. The donors are unrelated, so no one person's blood type says anything about the other. Yeah, if it's like a family of 5 came, 3 kids, right? There's likely to be, it's unlikely that all of them are going to be independent. And then you have a fixed probability, so 7% for any single one of them. So this is a binomial situation with n equals 200 and p is equal to 0.7. All right, to find the mean and the standard deviation of a binomial distribution, there's 2 formulas. The formula for the mean is n times p. So for the free throw situation, the mean is n, which is the number of free throw attempts, times p, the probability of success, so 3.75. So on average, our shooter hits 3.75 free throws out of 5 long term. That's the expected value. The standard deviation is n times p times 1 minus p. So in this case, my n would be 5. My probability of success is 0.75. My probability of failure is 0.25, so 0.97. So on average, out of 5, she hits 3.75 plus or minus, 1 free throw. In the blood drive situation, my n is 200, my p is 0.7, and yeah, we calculate that. So here the average would be 14 zero-negative ones, and with a standard deviation of 3.61. So 14, give or take 3 or 4. Here's the steps of going through and finding the mean and standard deviation for the free throw shooter. Now, a couple situations that are not binomial. So dealing 5 cards, counting hearts. So if I'm dealing from a deck and I deal 5 cards, all right, so it's a fixed number, but as soon as I deal one and I place it on the table, like for a poker hand, then that affects the probability that the next one will be a heart, right? So if I deal a heart, there's 1 fewer heart in the deck. So the probability of the next one being a heart goes down. Tossing a coin until I hit first head. So basically flipping a coin and then counting how many times does it take before it comes up as heads. So the issue there is there's not a fixed number of trials. Now I could flip a coin 10 times and count how many heads landed total. But if I keep flipping and counting until I hit like 5 heads, then that is not a binomial situation. All right. Let's look at this situation. We've got a drive, the blood drive. The mean is, the blood drive expects an average 14 O-negative donors. Use the output to find the probability that the drive gets exactly 14. All right, so out of 200, so we have a situation where there's 200 people with a probability of success, here defined as being a O negative donor being 7%. So I want to know what's the probability of getting exactly 14 out of 200. So exactly 14 out of 200 would be 0.1099. Let's see. So 0.1099. So roughly 10.99%. All right. The second hospital needs at least 12 of them from the drive. So I want to know what's the probability of getting at least 12. So now I want at least 12. At least 12, the probability is 0.7492. So 0.7492. Find the probability that the number of O negative donors is between 10 and 18. So now between, here we go. Between 10 and 18 inclusive. All right, so 7897. So between 10 and 18, so just about roughly 79%. So roughly 4 out of 5 times you're going to have between 10 and 18 O negative donors. All right, so binomial random variable, the count of successes that passes all 4 conditions, n number of trials. So you don't do it until it happens, and you set the number of trials. So for example, you're going to be shooting 5 free throws, and you just count how many makes you have after that. P is the probability of success, N is the number of trials. Independent trials, one outcome doesn't change another's probability. The formula for the mean is N times P. The formula for standard deviation is the square root of N times P times 1 minus P. So summary, binomial counting successes when all 4 checks pass. You've got the free throw situation. You can use the Staplet app to find exactly, at least, at most, between different things as well. And then you've got the 2 formulas for mean and standard deviation, and that is lesson 6.2.